The following is the video solution from JSDT Solutions. Question 8 says, in the diagram below, the circle passes through points A, B, C, D, and G. And then they tell us that AD is the diameter of the circle, and then BD and AC intersect at H. And we are given one angle, which is AGC, and that is 58 degrees. The first question, 8.1, says, determine given reasons the size of the following angles. And we need to first find angle B2. Okay, so looking at angle B2, look at where it is. It's at the circumference, okay? And do you see that it's being supported by AD, which is a diameter? So the angle in a circle at the circumference supported by a diameter is 90 degrees. Okay, so that's angle in a semicircle. And we can go ahead and tell them that. So angle B2 is equal to 90 degrees. And this is because of angle in a semicircle. And that is our answer. Moving on to the next question. Question 8.1.2, we have to find angle B1. So we're going to mark down that this is 90 degrees. And if this is 90 degrees, how do we find angle B1? So B1 is also at the circumference. It's over here. Now, you can see that we don't really have any other angle that is supported by DC that actually has a numerical value right now, this arc. So we're going to go ahead and relate it to the angle that is next to it. Do you see how it sits next to 90 degrees? And together, if you join A, B, C, G, we have a cyclic chord. And we know that the opposite angles of a cyclic chord add up to 180 degrees. So we can just tell them that angle B1, so angle B1 plus angle B2 plus that angle that we already have, angle G, which is 58 degrees, that should add up to 180 degrees. And this is because of the opposite angles in a cyclic chord add up to 180 degrees. And we're trying to find angle B1. We know that angle B2 is 90 degrees and angle G, not G8, angle G is 58 degrees. So this is equal to 180 degrees. So we're going to add these two together. So that will be 148 degrees. So angle B1 is equal to 180 degrees minus 148 degrees. So that's really just 40 degrees minus 8 degrees, which is 32 degrees. Okay, so angle B1 is equal to 32 degrees. And that is our answer. The next question, 8.1.3, says we need to find the size of angle A2. So we know now that this is 32 degrees. And how do we find angle A2? Now, do you see that angle A2 is at the circumference and it's supported by this arc DC? But we also have another angle at the circumference supported by the same arc DC, and that's angle B1. So this means that angle A2 is equal to angle B1. So that's 32 degrees as well, because of angles in the same segment are equal. Okay, so we just tell them that angle A2 is equal to angle B1, and that is equal to 32 degrees. So therefore, angle A2 is equal to 32 degrees, and this is because of angles in the same segment are equal. And that is our answer. Question 8.2 says, if it is given that AB is equal to BC, prove that AB is a tangent to the circle passing through A, H, and D. Okay, so if it is given AB is equal to BC, we need to prove, given reasons, that this line AB is a tangent to the circle passing through A, H, and D. So we'll have a circle here. Okay, so it's something like this. You don't really need to draw that circle, or at least not that big. It's not necessary. Okay, and we're really just trying to prove that AB is a tangent to this circle. Okay, so using the tan chord theorem, we can tell them that angle A3, right, the angle between the supposed tangent and the chord in the circle AH, that it's going to be equal to the angle in this blue circle supported by that same chord AH. So the angle supported by that same chord would be this angle over here, and that's just angle D. We can call it angle D because there's no confusion with that. Okay, so that's what we are required to prove. We are required to prove that angle A3 is equal to angle D. And if we can show them that that is true, then this means that AB really is a tangent to this circle. Okay, now we have also been told that AB and BC are equal. Since they are equal, this creates an isosceles triangle. And so these two angles will also be equal. So angle A3 is actually also equal to angle C1. And because of that, we have the center angle. We can actually find their sides. So let's go ahead and do that first. Okay, so we can go ahead and tell them that they are equal first. Angle A3 is equal to angle C1. And this is because of angles opposite equal sides are equal, not isosceles triangle really. And now since they are equal, we can add the angles inside this triangle. So we're saying that angle A3 plus angle C1 plus this entire angle give us 180 degrees. So that's angle A3 plus angle C1, and then we can just call this angle ABC. Okay, so we know that it's that angle ABC, that they give us 180 degrees, and this is because of the sum of the interior angles in a triangle. Okay, so adding these angles, we're saying that angle A3 plus angle C1, that they're exactly the same. So we'll just call them in terms of angle A3. So that's angle A3 plus angle A3, and that makes 2 angle A3, double of angle A3 plus angle ABC. Now that is 90 degrees plus 32 degrees, which is 122 degrees. Okay, so we know what that is, 122 degrees. And then now we can solve for angle A3. So if you transpose 122 degrees, that's 2 angle A3 being equal to 180 minus 122, which is 58 degrees. And then if you divide both hand sides by 2, angle A3 is therefore equal to 29 degrees. Okay, so that's angle A3. And now that we have angle A3, we also have angle C1, of course. Okay, to be honest, in this question, I really don't see the point of actually finding the numerical values of these angles. Because yes, we have angle A3 being 29 degrees, and that also makes angle C1 29 degrees. Then, if you look at this shape like this, in this circle that we already had, you can see that AB is supporting angle C1, and it's also supporting angle D at the circumference. So they will be exactly the same. So that's also equal to 29 degrees. So this is also 29 degrees. So we can just tell them angle D is equal to angle C1. So angle D equals angle C1, which is 29 degrees. And this is specifically because of angles in the same segment. And so the whole point of this is because we saw that the angle between this supposed tangent AB and this chord is 29 degrees, and the angle supported by that same chord in this circle is also 29 degrees, then that proves that this over here is indeed a tangent to the circle passing through A, H, and D. Okay, so at the end, we're just going to conclude that we can see they're exactly the same. So angle A3 actually is equal to angle D, and therefore it means we can just conclude that AB is a tangent passing through A, H, and D. Okay, AB is a tangent to the circle passing through A, H, and D. Now, we didn't use the tan chord theorem to prove this. We just showed them that the tan chord theorem is valid here. Okay, so we were able to show them that the angle between the tangent and that chord was equal to the angle supported by that same chord. Okay, that's the whole point of this. So the reason would be the converse of the tan chord theorem. And that is our answer. And that is it for question 8.